All right, so this next one is Pascal's triangle. And in Pascal's triangle, what we're basically doing is we're taking a polynomial and we're multiplying it, but we're multiplying it to itself repeatedly. You could say basically what this looks like, x minus 2 to the 5th power. What it truly looks like is it looks like this. X minus 2 times itself 5 times. And we could go through and multiply this, and then multiply this, and then the result that we get, multiply those, and then that result, multiply it by here. And you would get the correct answer. Just your work might start looking a little like it's taking a long time. It's a little maybe confusing. Now, what happens when we change this 5 to a 15? I don't think you're going to want to write this 15 different times. So Pascal's triangle allows us to find a more efficient way of solving these types of problems. So if you can remember how it is even built, is we start with a 1 at the top. Remember, it's a triangle, so you're forming a triangle. So you have a 1 at the tip of the triangle at the top. Then you have 1s on the outside of those, right below it. Okay. To the next row, start with a 1. You always start and end with a 1 on the row. And then in order to get the next number, you're going to see what we do is we write it right in the middle right here. And that's because it is what those two values add up to be. So 1 plus 1 is 2. And where I get this 2 from, again, is because 1 plus 1 is 2. And then next I end with a 1. Start with a 1. 1 plus 2 is 3. So we're going to write a 3 right there. And notice how it's in the gap there. Okay. Same thing here. 2 plus 1 is 3. So we have another 3 there. And then now we're moving to the next term, which is on the outside of the triangle. So we have a 1 there. So we're going to keep going with this, and I'll go to where we need to stop. So we have 1. Then we have 1 plus 3, which is 4. So 4 will go there. Next, we have 3 plus 3, which is 6. Now a 6 will go there. Again, we have 3 plus 1, so we have 4 out here. And then lastly, we have our 1, which is our outside of our triangle. Let's go one more, because that is how far we need to go, and I'll explain. So we have 1, and 1 plus 4 is 5, so 5 will go here. 4 plus 6 is 10, so we'll next write a 10. Again, 6 plus 4 is 10, so it's another 10. And then we have 5, and our last value is 1. So the reason why I stop here is because in this problem, it says that we need to have x minus 2 to the 5th power. So this is how it works. We always go to one more row than we have a power. So we have power 5, so we need row 6. So this is right here. This is the first row. Here's your second row. Here's your third row. Fourth row. Fifth row. And sixth row. So we have power 5, which means we need one more, which is the sixth row. So here is the row that we need. This is the row that we're going to use to help us with our coefficients. Okay. Now, that's great. We know how to write a triangle, but how do we use these values? So use these values, again, they help you with the coefficients. What also is going to help us is that we're going to use the first term and the second term in our binomial. Okay, so here's how I like to do it. Again, these are our coefficients, so you can see those written quite often. And I'm actually going to change the color of these so we can see these appear. Actually, let's change it even more. Let's change this to a whole different color. Oops, sorry. Something that stands out there. All right, so here's what I have. My coefficients first. So I have 1. This is my very first coefficient. Right here, I'm starting with a 1. And then what I'm going to do is I'm going to write both my terms here. I'm going to put them in parentheses, so I'll show you. X and -2. And you're going to continue this pattern. So let me show you. The next coefficient we have is +5. So we're going to write +5. And again, we're going to write our 2 terms, x and -2. I have a feeling I'm writing too big. I'm going to run out of room here. Continue the pattern. Next is 10. So I'm going to write 10. And then I have x, and I have -2. Sorry, I paused it real fast and rewrote it because I was definitely going to run out of room. So next I have 10. So I write +10. And then I write my 2 terms here, which is x and -2. My next term is 5 +5, and again, x and -2. My very last one, oops, didn't mean to erase, I meant to show you, 1. So we're going to use 1. And then we have x and -2. All right, now, this is great. Cool colors, fantastic. What does all this mean? We still have one more thing to do before we simplify. So we wrote x and we wrote -2 and multiplying together, but we also have to give each of those values an exponent. And this is how the exponents start. I'm going to change my color here. So we're going to start with our first term, which is x, and we're going to give it the same exact power that we were given. So 5. And then you're going to go through each term, which is x. So each term x, and just count down from 5. So 5, 4, 3, 2, 1, and 0. Okay, so that's how you set up your first term. How you set up your second term, I like to keep counting down, so I just go backwards. And what I'm going to do is, and let me change the color here, see if I can get something that pops out a little bit more. I have 5, 4, 3, 2, 1, and 0. Okay, this again is just to set up. This is not even doing really any math computations at all, other than setting up the triangle. We haven't done anything but count. Now, one thing you can notice is you might say, what if I get confused with the numbers that go in the exponents? What if I get all mixed up? They should always add to whatever value you have here, which is 5. So 5 plus 0 is 5. 4 plus 1, 5. 3 plus 2, 5. And you can see they all equal 5. All right, that's another way you can check. Then once you have this, now you have to simplify the exponents, which is really where the true math comes in, I feel like, where you have to make sure that you know what you're doing. And if you need a calculator, use a calculator for when you have values. So we have 1 times x to the 5th power, which is x to the 5th, and then -2 to the 0. This right here is 1. Anything to the 0 power is 1. So really it says 1 times x to the 5th times 1, which this will give us x to the 5th. Next, we have 5. I look at my here. This is a variable, so I'm going to try to look at my coefficients first. My values here. So I have 5, and I have -2 to the 1st power. -2 to the first power is just -2. So what I essentially have is -2 times 5, which gives me a -10. And then I still have x to the fourth power. And we're just going to continue this pattern of multiplying the values, and then we still have a variable with an exponent. So we have -2 squared, which -2 squared gives us 4. We have 4 times +10, which gives us a +40. And then you have x cubed. Next, we're going to look at this here. So we have -2 cubed. So -2 times -2 times -2. This gives us a -8 because -2 times -2 gives us a +4. And we have to multiply by -2 again, gives us a -8. So this is -8 times 10, which gives us a -80. And then we have x squared. Now next we have -2 to the fourth power. And -2 to the fourth power is +16. This right here is +16. And then we have times 5. So we have +16 times 5, which gives us a +80. And then we still have just x to the first power. Last here, we have -2 to the fifth. And -2 to the fifth is 32. Sorry, -32 times +1 will give us a -32. And like we said previously, anything with 0 power is just 1. So x to the 0 power is just 1. So there is no variable back here. So this is your solution to x -2 to the fifth power. Not a lot of work to show compared to if you were to do x -2 times x -2 5 times, right? You'd have, if you're going to use our box method, if you're going to use the distributive property, there is a lot more room for error there. But Pascal's triangle allows you to use this a little more efficiently, meaning that it's quicker and there's not as much room for you to maybe add incorrectly or subtract incorrectly.